Hi, welcome to this lesson on statistics, mixed exercises part 1. Let's have a look at question 2. The wind speed in kilometers per hour and the temperature in degrees Celsius for a certain town were recorded at 1600, 4 p.m. for a period of 10 days. The information is shown in the table below. So you have your x variable being the wind speed, so that's going to be your independent variable, and your temperature y is going to depend on the wind speed at 4 o'clock in the afternoon on that specific day. Okay, so for the 10 days here, so when the x speed was 2 kilometers per hour, then the temperature was 28 degrees Celsius. Similarly, if the temperature was the wind speed was 11 kilometers per hour, the temperature was 24 degrees Celsius, and so on. They want us to determine the equation of the least squares regression line for the data. Okay, so we can do that. So click Shift, clear everything up. So now we're going to start afresh again on our calculators and make sure that you got the table values within visible order so you can put them in nicely. Okay, so we're going to click Mode Stat2 for a plus bx. And then again, all the top values here are your x. Right, so that's going to be your x and that's going to be your y. Okay, so I'm going to go 2, 6, 15. Again, just be very careful when you're inputting these data points to make sure you don't make any typos or errors. 25, 17, 11, 24, 13, and 22. And I can see I've got 10 data points, which matches up to the period of 10 days here. So I know that at least the number of data points I put in is correct. Okay, so 2 is associated with 28, 6 with 26, 15 with 22, 20 with 22 again, 25 with 16, then 17 with 20, 11 with 24, 24 with 19, and then 13 and 26, and 22 and 19. Okay, so I'm pretty confident that I've put everything correctly, but again, always take the time to just double check and make sure that you've put it in all correctly. So I'm going to click AC. So recall, the least squares regression line is y hat equals a plus bx, where the a and b values are found on your regression now in the calculator. So y is going to be equal to, so I'm going to click Shift Stat, Regression, and then find my a parameter. And that's going to be 29.35 to 2 decimal places, 29.35. Then for the b value, I'm going to click AC, Shift Stat, Regression number 2 for B, and it's negative 0.46, negative 0.46 to 2 decimal places times x. So there is the equation of your least squares regression line. Now it's asking us to predict the temperature at 1600 if on a certain day the wind speed of this town is going to be 9 kilometers per hour. And notice again, when we are predicting, right, this data here, the 9 kilometers per hour is quite reasonable within the already established data points. So that's why this least squares regression line is going to give us a pretty good estimation of what the temperature would have been that day if the wind was 9 kilometers per hour. If I'd asked you if the wind was, let's say, 80 kilometers per hour, then the prediction will be quite off because notice 80 is an outlier. It's quite far away from the given wind speed data points. Okay, so simply when x is going to be equal to 9 kilometers per hour, on my calculator, how do I do that again? So I'm going to click AC here, then I'm going to click 9, Shift Stat for regression, and then click 5. So again, this 9y hat, what does it mean on my calculator? It means that when x is 9, it's going to evaluate the predicted value. So I don't have to put it into that equation and type it all out. So I push equals and I get 25,2. So therefore y hat is 25,2. And don't forget to interpret your answer based on the context of the question. What is that y hat value? That's the temperature. So it has a specific unit, degrees Celsius. Similarly for x, it was 9 kilometers per hour. Okay, so we just want to be as formal and rigorous as possible when we do these calculations. We want to establish units and all that good information because this data is relevant to the real world. When reporters and analysts report on the data, on the statistics, they have to be as thorough as possible to make sure that they are giving factual information to whoever is looking for that information. Okay, and then lastly, they want you to interpret the value of B in the context of the data. So our B value, we actually worked out to be negative 0.46. Remember, this is a straight line equation, so that negative gradient means that there's a negative relationship. And if you remember on your XY axis, your X is telling you the wind speed and your Y is telling you the temperature. So what is the interpretation here based on the context? It's saying that as X increases, so as the wind speed is increasing, your temperature is decreasing. Okay, so as a statement you would say here, so as wind speed increases, the temperature decreases. Okay, and that is the pattern that we observe based off this least squares regression line. All right, so this has been question 2 for mixed statistics exercises part 1, right? Remembering that the important information that you're looking for in your table is your independent variable, your dependent variable, so that when you put that information into your calculator, you don't mix them up. If you mix them up, you're going to get radically different answers. Okay, so it's so vital when you're reading the information in the question that you establish X and Y correctly before you put the data in. All right, I'll see you in the next one.